Pipe programming. A look at object passing and transformation. A pipe is a connection between two programs, and through that pipe we send an object that is altered along the way to serve some final purpose. Imagine checking email. You create a pipe between your computer and the email server, and then you send a request object with your password and username. The email server will respond with an object that contains your emails. So we have programs connected by pipes through which we send objects. When you are writing a program, you are creating a pipework that connects smaller programs inside it. And then when your user uses your program, as they interact with buttons and such, they send objects down the pipes that you have created. While you can make a beautiful little program that takes good care of usernames and passwords, including their validation, you don't have to do it. There's a crude and perfectly functional way to do it just with the basic operations. When a user clicks login and initializes an object down the login to email pipe, rather than doing something special for the username and password, simply inject a new property to the object that the user initialized. The first time you inject the username. Second time you inject the password. This is a generic injection program where you specify the name of the new properties and move along. And then you follow up with a pop-up box that knows how to ask for all the properties traveling down the pipe. Nothing here is related to passwords. It is just properties in a standard form. When working with pipes in a graphic environment such as Node-RED, you can group the generic operations together and save them as a program called a subflow. The name of this subflow would be Ask for Password. It is perfectly reusable. Any object sent through it will receive an injection of username and password properties, and an automated pop-up will force the user to fill in those bits of information. Pipes, programs, objects. Those three crazy simple things is all it takes to make computer programs. This simplicity also reinforces efficiency. In more advanced programs like video editors that use pipes, Blender is a good example, pipes enforce the idea that a video is never sent whole, but only one frame at a time. The video can be 100 terabytes in size, but Blender will only take the memory needed for one frame, not the whole video. This is what the word streaming means. You are streaming a frame at a time down a connection pipe, rather than the user downloading the whole video. This can be done for efficiency reason or for the fact that the rest of the video does not yet exist. The black window command line that you see hackers use on TV is so powerful because it uses pipes. It uses the actual pipe character to separate programs, and objects tend to be lines in a file. For example, to guess a weak password, a hacker would have a common passwords dictionary file, and it would be just one password per line. They would then pipe the passwords to a login program. Each line in a file is treated as an object. The program reading the file would send objects one at a time to the program trying to log in. With a successful login, the login program would break the pipe and exit with a happy message. And none of the other passwords would continue being streamed as the pipe is simply broken and everything exits, including the program that is sending the passwords. There are many ways that the concept of program, pipe, and objects are represented. There are as many variations of this idea as there are programs that make use of it. Old school programmers don't like pipes. They prefer to load an entire movie into memory, process it, and be done with it. This is not a terrible idea. Operations on a video file in RAM are much faster than sending frames at a time through pipes. Others hate the idea of just having three simple things: program, pipe, and object. They are used to creating entire virtual systems with hundreds of objects, including password object, username object, a login object that contains both, and so on. That's their whole job, really. And then somebody else has to debug it. You know, they even create a server object that is a virtual representation of the mail server. It's objects everywhere. Just having program, pipe, and object is terrifying to them. But having just three things allows for those standard primitive operations like inject or branch, depending on whether the login failed or succeeded. There's a very small number of them, and they are very powerful when all mixed together. FFmpeg, a command line video encoding utility, uses pipes in the single most terrifying way. They construct trees of pipes, or meshes really, and it is all in a single line of text. Wow. And FFmpeg allows for multiple video inputs too. Whew. But once you know it is just three things, you are able to imagine everything in your mind. FFmpeg makes it so that input files are numbered from 0 up, and it names results of transformations, giving you a named connection point to which you can hook in a pipe to another operation. So you say 0, which means the first file that was mentioned on the command line. Then black and white, as in transform video to a black and white movie. And then you name the output of this transformation, BW, for example. Now you say BW, just like you said 0 a moment ago, followed by add movie grain, just like we just said black and white. And then you give it another name, GBW. And now you can use GBW output point to connect it to some other transformation. Here we think in threes: input name, transformation, output name. So the output name is the name of the transformed data. We are focusing on connecting transformed data to other transforming programs. Our named output is connected to another program as input. And sometimes names are optional in sequential operations. It makes them easy to read so that you don't have to keep naming the outputs and referencing them in inputs again. It would be a fun project to create a Node-RED-like user interface for FFmpeg. While you have exactly that in Blender, this program would crown FFmpeg with neat graphics. It is actually possible to reduce entire Node-RED programs to hard-to-read command lines. It would totally work. That is the power of keeping things simple. Keeping down to a very primitive but capable system helps prevent leaky abstractions. I think all abstractions are leaky. It is just the nature of abstractions. So the simpler you go, the less you have to worry about things getting weird. What you have glanced here today also translates to phone apps. A screenful or a card would represent a program. Swipes left and right would show you the incoming and outgoing connections. A pinch out or zoom out would show the entire network of pipes and programs. And if you create a hub for program card programmers, where people can set bounties on cards they need, you have a marketplace. By having this ability to request custom cards, all your users become programmers.